Good morning, everyone. I'll call to order our Planning Committee and Special Board meeting of January.
Just keep going.
Just keep going. Okay. I'll call to order the meeting for January 27, 2026. Terry, could we have roll call, please?
Good morning. May I, excuse me, let me clear my throat for a minute. Vice Chair Ranjit Kush.
Here.
Director Diana Mayer.
Here.
Director Matt Sampson.
Here.
Director Jed Smith.
Here.
And don't do that.
All right.
And currently not present is Director Larry Russell or Chair Larry Russell.
It's hard to talk, but we will keep going. Terry, are there any, first, are there any board comments on today's agenda? Terry, any public comments on today's agenda?
Not on today's agenda.
Then could we have a motion to approve the agenda, please?
So moved. Second.
Roll call vote, please, Terry.
I'm sorry, I couldn't hear you for a minute. Director Kush.
Aye.
Director Mayer. Aye. Director Sampson.
Yes.
Director Smith. Thank you. Can we pause this meeting for a minute just so we can check why there's a sound?
Of course.
You're okay. Thank you.
Just adjourned for a minute.
There is public comment on non-agenda items is what you're asking?
Yes.
Yes, we have two. Phil Sauter and Larry Minikis, please.
Good morning. At the July 22nd meeting of the Planning Committee, the committee chair requested staff to present a deeper dive into our industrial, commercial, institutional, and irrigation customers. These users represent 25% of our total water use. In the 6 months since that request was made, we've learned four things. One is our projected per capita water use is at 106 gallons per capita today, and that's currently what we project 20 years from now, even though there's a statewide push for increased water conservation. Two, we're holding our recycled water use at 2.5%, even though the statewide goal is at 15% and growing. Three, we've run into significant headwinds in our search for additional reservoir capacity. And four, our projected investment in bringing additional water from Sonoma has been steadily growing. So I'd like to once again ask that a deeper dive into this important customer segment be brought before the Planning Committee. And if there's a lack of interest in better understanding this important customer segment, especially its potential for reduced potable water use, I'd appreciate that some signal as to why we no longer think that's important to look at that. Thank you.
Thank you. Larry Minikis, please.
Phil, that was so short. Good morning. I just want to call out the work that's being done today, the pile burning on a turret trail. I had an opportunity to be up there. I saw the work that was done in preparation. It's really impressive. There was a lot of dead dying wood up there. And I want to suggest also that if you've not done so, take a look out at China Camp, what's going on, especially along the shoreline trail. Some might find it dramatic. It's a big change in the landscape there. Fantastic. There are literally hundreds of piles. They've been doing pile burning out there. And it's just really impressive because, as you might know, China Camp has suffered tremendously from sudden oak death and from drought on top of it. So they're not only taking out old oaks, they're taking out madrones that have been very drought stressed out there. It's a big change out there. Thank you.
There are no further speakers.
Okay. I need a motion to approve the minutes.
So moved.
Second.
Roll call.
Vice Chair Kush.
Aye.
Director Mayer.
Aye.
Director Sampson.
Yes.
Director Smith.
Aye.
Chair Russell.
Aye.
Thank you.
Okay. Water treatment plan update, master plan update.
Good morning, Chair Russell, board members,
Hi,
Alex Naya, Engineering Director. Here this morning to provide an update to the water treatment master plan is our Engineering Manager of Planning, Alicia Irish.
Good morning. Alicia Irish, Manager of Planning and Engineering. I'm here today to give a water treatment master plan update. We'll be going over some background of the treatment plants, discuss the 2015 water treatment master plan, and then talk about looking forward into the future and next steps. As you know, the district has 3 water treatment plants: Bontempi, San Geronimo, and Ignacio Pump Station. And these range in nominal capacity from 16 million gallons per day to 35 million gallons per day through 1976. These 3 treatment plants each receive source water from various different sources: Bontempi from Bontempi Reservoir, San Geronimo from Nicasio and Kenton Reservoirs, and Ignacio Pump Station from the Russian River. Bontempi and San Geronimo, they utilize traditional water treatment processes of rapid mix, clarification, filtration, and disinfection. And the Ignacio Water Quality Pump Station provides enhanced disinfection as it receives treated water. This slide here, which was recently presented in a Board of Directors meeting, shows a high-level overview of those traditional treatment plant processes and how they work together. It first starts with the source water at the lakes and then moves into rapid mix and clarification to filtration and finally disinfection prior to moving into the distribution system. So now to the 2015 report. In 2015, the district completed the San Geronimo and Bontempi water treatment plants master plan report. And this report provided a comprehensive look at both the Bontempi and San Geronimo water treatment plants. It evaluated aging infrastructure reliability, seismic resiliency, operational reliability, as well as water quality. And one of the key assumptions in this report is that Bontempi was the district's emergency treatment plant, primarily due to its ability to feed the southern part of our system via gravity in the event of a power outage. As a result of this report, there were project-specific recommendations that range from structural, architectural, mechanical, power supply, and instrumentation and control upgrades. Some of these completed projects at both plants include structural improvements to our control rooms, filter galleries and pipe galleries, filter rehabilitation at both plants, as well as arc flash electrical upgrades. Other projects, like the very large project of installing new clarifiers at San Geronimo, have yet to be completed. Also, since 2015, there have been other projects completed at the treatment plants that were outside of the report scope. The most notable one is a 3-megawatt generator installed at San Geronimo, and this project was completed in 2023. And this project provides a way to keep San Geronimo treatment plant in continuous service in the event of a planned or unplanned power outage, such as the PSPS events. And this ability to remain in continuous service, as well as the larger capacity of San Geronimo, has effectively changed that 2015 assumption from the district's emergency plant from Bontempi to San Geronimo. Additionally, we see that the climate is changing. And we know that in the future, there may be more frequent dry weather, increased taste and odor events, algal blooms, and increased regulations. And this creates a need to reevaluate the risk of water quality issues and also evaluate the potential move to new disinfection practices. One of those potential practices, ozone, would reduce taste and odor issues, algal bloom effects, as well as reduce disinfection byproducts. Implementing a new practice like this would require a comprehensive evaluation of the plant's layout, as the hydraulic grade line or the elevation of water as it moves through the plant may need to be adjusted. Also, since 2015, we experienced an historic drought. And the strategic water supply assessment completed in 2023 as a result of this drought to strengthen our water supply resiliency has some proposed projects that rely more heavily on the district's reservoirs of Kent, Nicasio, and Suluhuli. And these projects, if implemented, increase the criticality of the San Geronimo treatment plant, as well as the transmission line of the North Marin line. So in summary, we know that treatment plants are inherently complex. This photo on the right shows the filter rate control valve, just one of them, at San Geronimo treatment plant. And this one valve alone has electrical, mechanical, and instrumentation and control needs. And there are thousands of these discrete type of components at each treatment plant that need to be working continuously to provide service to our customers. We also know that 2 of the 3 district's treatment plants are approaching 70 years old, with few significant upgrades since its initial construction. And to assure reliable and resilient service into the future, these treatment plants require further rehabilitation. Further, the 2015 report only discussed Bontempi and San Geronimo, leaving out Ignacio Pump Station. And while that report stated that the water quality standards are being met, there were no recommendations for projects related to taste and odor issues. Additionally, some of the projects completed outside of the report's recommendations, along with a need for increased water supply resiliency, have changed the way that staff think about how water moves around the system and the associated treatment plants. As such, there's a need to update the 2015 Water Treatment Plant Master Plan. This update is not a whole redo. It's merely an update that will assess the conditions and needs of these assets and also strategically prioritize projects using a risk-based approach model, as we've seen in the Water Distribution System Master Plan. Staff have issued a request for proposals for the Water Treatment Plant and Transmission System Master Plan issued on October 28th of 2025. Proposals are due this Thursday, January 29th. Once received, staff will review the proposals, interview potential consultants, and return to a future regularly scheduled board meeting with a recommendation. Thank you.
Jed?
Okay.
I'm good, thanks. Pat?
Yeah, thank you for the presentation, Alicia. I'm still not clear on the purpose of this update in terms of actually what you're trying to get out of it. It seems like there's some generalized things, but some of the stuff I'm not sure what you're hoping to get out of it.
So what I'm hoping to get out of it, if we move forward with this, is kind of a relook at the treatment plants as they stand now, and also incorporating in some of the other initiatives that we are pushing forward with, such as water supply resiliency. And if we don't have a risk-based approach model that looks at all of the smaller assets within the treatment plants, it's not impossible to do projects at the treatment plants, but what it doesn't have is a plan at which to move forward. So we know, for example, that we need new chemical rooms. We also know that we're looking to change some of the chemicals that we use, like from aqueous ammonia to liquid ammonia sulfate. We also know that we want new clarifiers and that assets are aging and are in need of rehabilitation. And so how does staff strategically go about doing all of those projects without going down one avenue and closing off opportunities for other future projects? What we want is, a really kind of holistic look at all 3 of our treatment plants and how we want to move water through them and what do we want to set ourselves up for in the future, not just sort of maintaining what we have. So if taste and odor issues increase, which it looks like they might, there is a need to really look at, do we want ozone? Do we want something like ozone? Do we want to change what we're doing today? And if we want to, that's going to change most everything about the treatment plant, where everything is laid out. And we wouldn't want to install new chemical rooms if that's going to be on the table. So we really want to just kind of collect all the pieces together, know the state of everything, and then make a strategic plan, just like we're doing for our distribution system, just like we're going to be doing for our dams, and really have, a comprehensive plan moving forward that it is also defensible. It's, it's using the risk-based approach model, and we can really stand behind it. And that would unify staff's plans moving forward and would also allow it to be incorporated into the larger capital program.
Gotcha. That's more helpful. I just, 10 years, these strategic plan or these plans or overviews, they're stale, becoming stale. I get that part. I'm trying to figure out what staff can't do that this consultant is going to be paid a ton of money to do. And that's where I'm getting hung up on. Like, you talk about, we know our needs, we know what we're considering. I'm trying to figure out where the consultant's going to add value for the price tag on this one.
Are you looking for more? I mean, I thought, I appreciated Alicia's response to the question, because I thought it really conveyed in large part what I was thinking too, in terms of the response to the question, because I think it was a really good question. Because master plans, what are they really? And you already have one. What are you getting? But God, our treatment plants are so critical, and we really haven't invested in over the years. We have a master plan. During a large part of that 10 years, we were resource constrained a bit. And as you heard, there's a lot of changes from then to now in the kind of externalities and opportunities out there. So I do think it makes sense. At the same time, staff is not saying we want to redo. No, we just want to update it in a really thoughtful way. And really, I think, ensure that we can replace a roof, we can put in new tanks, but really this thoughtful look at the appropriate sequencing based on policy direction on what initiatives, the board wants to think about, like ozone kind of thing, I think really lays out, the next 10 to 20 years of investment for us on these critical facilities.
Gotcha. And I get that. I'm fearful 10 years ago, we had the same conversation about now we're ready for 10. And
Absolutely.
so with this, do we have the opportunity to look at, like the solar component to San Geronimo? Is that going to be considered for things like this?
We'll be looking at that. And we also be looking at our transmission system, or the pipes that feed into the treatment plants, which are very critical and important as well, and kind of giving a condition assessment to those. So it just sort of complements all of the other types of initiatives that we've been doing, with the thought that in the end, we'll have a long-term CIP, right? We'll be able to project out 10, 20 years on what our investments are. And it's not necessarily going to be like pipelines you can do, 5 miles a year. Treatment plant projects, they're kind of one-off, they're larger. You really need to think about how you're going to invest in it. Like the clarifiers, for example, it's a $30 million project. That's kind of your hit at it at that one time. And so thinking about the sequencing, thinking about the timing, how projects need to interact with each other are all things that we would get out of this update.
Thank you for the additional information. Appreciate it. That's it.
Alicia, I thought you gave a very thoughtful justification for developing the plan. Hard to argue against that. And then, we heard that from the last plan, some pieces of it were implemented, some were not, for reasons that Ben has already noted. Do you have a sense of how far we got with the last 10-year last plan in terms of being able to carry it forward?
We did filter rehabilitations at both of our plants, which was no small effort. And we should really be proud of ourselves for doing that. And we've also done structural upgrades, some electrical upgrades. And so we've gotten, a number of the kind of low-hanging fruit done, but we're to the point of like the clarifiers, right? How do we want to do that? And if there's going to be other changes, are they just going to go back where they are as they are? Those are questions that we're going to be asking ourselves, as we embark on that project.
Right. Great. Yeah. Well, I'd love to learn more about ozonation and what that entails, but I know Larry's going to have a lot of thoughts on it, so I'll hand it over to him.
And you're right about that. I think it's a breath of fresh air to take a look at it this way. I think you short sell ozone. It has a lot more benefits than taste and odor. And as it was put to me one time, it causes the water to sparkle.
and I don't know how else to describe it, but it does. It changes the physical appearance of the water in a way, and every plant in Europe uses it. It's standard practice. And it's not because of DBPs. You know, it's the change in the appearance and the aesthetic side of the water. So I think it's a great idea. Who did you send the RFP to?
The RFP was sent to about a half dozen firms from email and was also posted to our BPX website. The last I checked, there were about 30 plan holders.
Oh, good.
We'll see
Good.
the kind of response we get.
Because this is a little out of what I'd call the big firms.
Mm-hmm.
They can do it, but it's not something they would feel, I don't think, comfortable with. So, I mean, they would get something done, and they'll probably respond to the RFP. But it's good that it's posted, because I have some thoughts on who could likely be able to do something like this usefully, and hopefully they respond. So with that, I think it's a great project. And what's the budget for it?
We've budgeted across our CIP about 800,000 over 2 years. We'll see if that
Yeah, I
is
don't
going to
think
be.
it's
I
not
don't
gonna
think
be
it's
that
going to
big.
be that big,
No.
but we'll see.
Yeah, unless they feel greedy, you know. But who wrote the last one?
MWH.
Yeah, Montgomery would be one of the, Stantec would be one of the ones that has the intellect to do it. Whether they have the interest or not is a different issue. Okay, public comment?
Yes, Phil Sauter. And Larry Minikis.
Thank you for the great presentation. It's really interesting to note all the changes since 2015 and the need to update the master plan to reflect them. One significant change is that 25% of our water supply is now coming from the Sonoma watershed, and we're planning to increase that to 30% over the next few years. Another issue I hope will be addressed is PFAS. I don't think these were on the radar in 2015, but they are today. I recall hearing from Ben last year that Marin water has no PFAS, but I don't know how many of these compounds we test for. I believe Sonoma water tests for 5. It would be good to know we're in sync and that we eliminate as many of these compounds as we can. Another issue that will be addressed is taste and odor, which seems to be discussed more than it was in the past. In 50 years as a Marin water customer, I've always thought my tap water tasted as good as any bottled water I've ever tried. I was told that out in the San Geronimo Valley, we don't get any of the water imported from the Sonoma watershed. And it made me wonder if that could also make a difference along with algal blooms. And if perhaps the treatment protocols we're used to for our own Marin watershed may need to be adapted for water from outside sources. Thank you.
Well, I live where we only get Russian River water, and I don't think there's ever been a problem with taste and odor.
Okay.
I'm pretty sensitive to that.
Okay.
It's the reservoirs is where the taste and odor comes from, the blue-green algae that grow in the reservoirs.
And that is from the time that it happens. Is that also a time that we could be using more Sonoma water when the taste issues arise?
The system's not quite set up for that.
Okay.
You know, the Russian River water stays in the east, along the east side of the district. To get up into the other parts is hard. They're not really set up to pump it up the hill.
I just thought it might be worth looking at.
But the ozone it's kind of like using a sledgehammer to kill a fly. You know, it's a broad-based oxidant that attacks everything, including PFAS, if they were there.
Well, thank you, Alicia, for the presentation. And Larry, talking about sparkling water, it looks kind of sparkly now, but it did make me wonder if the tactile feel will change too when you're taking a shower. Because some of you notice when you travel different places, there's a feel to the water when you shower. So that's one. But I want to actually speak to this item and the next item and what we saw happen at the beginning of the year and the new phrase we've all learned, which is single points of failure, because we saw what happened with the AT&T substation during really what was a local kind of disaster here. And really something that should be on everyone's mind is to make sure that we've hardened our facilities, we're ready for whatever may come our way, and that we avoid at all costs single points of failure. Thank you for that.
Yeah, that's an interesting comment, Larry. If you go to the El Pollo Loco in San Rafael, it has flood barriers for El Pollo Loco, right? But AT&T didn't. And it was fascinating to me to find out that San Rafael had dikes, as does Corte Madera. And I mean, they're obvious when you look at them, but I didn't realize that's what they were. I just thought they were, kind of like bird paths or something. But it's quite interesting how much work's already been done. There was a fascinating question at the last NBWA meeting. They asked Professor Lund from Davis if Corte Madera should invest the money to upgrade the dikes to current Corps of Engineers standards. And his recommendation was absolutely. They're that serious. The dikes are right down here, just across the freeway. Yeah, you see them running parallel to 101. And they do a lot. And like I say, it's not really obvious what they are until you see them as what they are. And the same thing with San Rafael. Like I said, I was amazed. The network of dikes that exist in San Rafael to protect it against flooding. So that's why it's always good to look forward, and appreciate your comments. Okay, cool. Let's go to Tokoloma.
Okay. So now this has been a project long time in the making, and Zach, our engineering manager of design, will be presenting the Tokoloma Pump Station Rehab Project.
Hi, Zach.
Good morning.
Oh, turn on. There it goes.
Oh, wait.
That's on.
Good morning, everyone. Thank you, Alex. Today we'll be talking about the district's second largest pump station. It holds 6 vertical turbine pumps with a total of 2,200 horsepower and is capable of moving 20 million gallons of water per day. It's considered one of the backbone components of our infrastructure for raw water supply to San Geronimo Treatment Plant. The pump station has been in continuous service for the last 65 years, and this project aims to fully rehabilitate it. When it's all said and done, the district can reliably pump water through Tokoloma for the next 65 years. All right. So in today's presentation, I'll be going over background and history of the Tokoloma pump station, the existing infrastructure, our project scope, construction timeline, and staff recommendation. The image here is of Tokoloma pump station. The green building that you see in front of you is what we'll call the pump house. It holds the 6 vertical turbine pumps. And then just to the right of it, it's kind of hard to see, is this CMU building. That's the electrical building. And then in the foreground there, or in the background, is the PG&E substation. So the substation directly feeds power into the brick building and then feeds power to the pumps. So in a nutshell, Tokoloma Pump Station conveys raw water from Sewahuli Reservoir and Nicasia Reservoir to the San Geronimo Treatment Plant. And as I mentioned, it can supply up to 20 million gallons per day of raw water to the treatment plant. It's probably the second biggest. The first one would be at North Marin Booster Pump Station at San Geronimo. To dive a little deeper into this map, you have Sewahuli Reservoir here at the top. And this yellow line is actually the discharge piping for the Sewahuli pump station. And we have the ability to pump raw water from Sulahuli Reservoir into Nicasio. And the reason why the water or the line doesn't go all the way to Nicasio is because it becomes open channel flow into the reservoir. And then from there, you have Nicasio Reservoir. And this green line is what we'll call the inlet piping for Tokeloma Pump Station, which is located here at the intersection of Sir Francis Drake and Platform Bridge Road. It's fed via gravity from the head of the dam and reservoir. And at Tokeloma Pump Station, it boosts pressure and flow up to 20 million gallons per day. And it flows along Sir Francis Drake Boulevard all the way to San Jeronimo Treatment Plant. I'm showing Kent Reservoir here and this magenta line because we have the ability to supply San Jeronimo Treatment Plant with either Nicasio Reservoir supply water or Kent Reservoir. They combine right here at what we call the shafter valve, and that valve allows us to isolate either reservoir and run San Jeronimo Treatment Plant from one or the other, or both if we want to. So constructed in 1961, it's comprised of a pump building with the 6 vertical turbine pumps, electrical control building, which holds the switchgear, motor starters, and remote telemetry unit, and the PG&E substation. This is a drone imagery photo of what you kind of saw on the first slide. So here's your pump house, your electrical building, and the PG&E substation here.
What voltage is it supplied?
It's medium voltage, 2400.
That's why the substation's there.
The substation's there for the power. Exactly. Okay, now we're inside of the green building. This is where the 6 vertical turbine pumps are housed. What you're actually looking at here are their motors. So right here is pump number 1. That's the 200 horsepower motor. And then in the background, you got 2 through 6. All of these pumps and motors are original to the 1961 build, including their control valves and isolation valves. During this 2-year process, we did do a full condition assessment of the pump station, and these pumps tested between 61 and 67% efficient, which is considered poor. Anything under 70% efficient is you're kind of in the replace or rebuild range. Just for your knowledge, when you buy a brand new pump, you're around 85, 86% efficient. And because of these inefficiencies, it increases the district's PG&E power usages and also decreases the flow capacity.
Can you just go a little more on what we mean by pump efficiency?
Yeah, sure. So over time, you've got impellers within these pumps, and the impellers are made of metal, and they'll break down due to cavitation or just natural wear and tear. So those impellers don't have as much surface area on it to pump the water as efficiently as possible. So you're actually turning on maybe another pump to pump the same amount of water as you were previously when those pumps were brand new.
Just to add a little bit, that equates to adding more energy and more need for electricity at this pump station because of the inefficiencies. So with newer pumps and motors, efficiency goes up, energy consumption goes down.
You can see it. Talking about throwing third
A lot.
for the power that's used. So
So within the pump building, we're mostly looking at replacing all the mechanical equipment. The pump building itself was actually in really good condition. It's reinforced concrete.
relatively speaking,
Yeah, relatively speaking. Reinforced concrete building, and the metal roof was in good condition. It just needs to be recoated. We're looking to replace pump 1, 2, 3, 5, and 6 with new pumps and motors. All these new pumps will be factory tested to a minimum of 86% efficiency rating prior to acceptance and installation. This is looking to reduce our PG&E electrical and energy consumption. This, coupled with our VFD drives, which I'll talk about in a couple of slides, will reduce our PG&E energy consumption by up to 20 to 30% and maximize our available flow. And you may be asking, what does 20 to 30% look like? I took a look at the numbers last week. Over the last 5 years, this one pump station has an average of $1 million per month in electrical PG&E charges. So our monthly charges can be expected to drop to about $700,000, so $300,000 a monthly savings in PG&E's electrical charges due to replacing the pumps and switching over to VFD drives.
are all the pumps used all the time?
Depending on the demand, but if you look at prime demand, most of the pumps are on. 4 to 5 of the pumps are on, with one being off during summer flow season. Okay, now we're inside the electrical building. It's comprised of unreinforced concrete masonry unit walls, which are not seismically resilient. It also has a wood framed roof structure. This houses the original 6 motor starters, and there's one for each pump. I like to think of these as standard light switches. So when you turn the switch on for one of the pumps, it turns on immediately and it goes to full speed. And there's no changing that full speed. So it's running at 1800 RPM, and there's no ability to control it. The VFDs are more akin to what you would consider like a dimmer switch. So you actually have the ability to slowly turn on the pumps, which reduces your electrical demand charges. And you could also reduce the speed of your motors, which reduces the speeds of the pumps, and you could actually dial in flow. At the time in 1961, this was state-of-the-art technology. Fast forwarding 65 years, what we're looking to do is to put it in modern times with our VFDs. And because you cannot control the speed of the pump, you have limited flow control. So I actually have a small chart here to the right, which is in general what the pumps are capable of. So if you want 12 million gallons of flow rate per day, you turn on 2 pumps. But let's say you wanted 12.5 million gallons to match supply. You can't actually achieve that. You have to jump up to 13.8 by turning on that one small 200 horsepower. And as you go higher up in the flow range, you actually lose control. You get less and less control. And you could actually see that it jumps from 13.8 to 15, then 18.
Is that an operator decision, or SCADA runs it?
It's operator through SCADA. So the operators at the treatment plant actually set the control.
Push a button.
They push a button and they'll turn on. So essentially they have the ability to say, turn on pump 1 and 2 and 3. And then what the flow rate is what the flow rate is. There's no control over it.
I think you should also point out that what goes along with the PG&E bill is the demand charge.
Correct.
Which is substantial.
Correct.
And this is exactly what you're talking about, is reducing the demand charge. There's 2 measurements on electric meters for big power like this. One is the amount of kilowatts used. The second is how you use it.
Correct.
And they nail you for your highest demand for the month, whatever that number is. So when you flip that switch, you create a huge inrush of current.
Correct.
And a huge boost to the bill.
Correct. Yeah, that's exactly right, Director. And the VFDs will allow us to slowly ramp up that motor, which reduces that inrush and those initial charges. And my last bullet point here is because there's limited flow control, when we want to use both Kent and Nicosia Reservoir, it becomes difficult for blending because you don't actually have any control how much of one reservoir you're getting from the other. It's it is what it is, and then they kind of adjust to it, and it takes time.
And how are you going to address that?
With the variable frequency drives, you can.
I see where you pull from, huh?
So this is a schematic of what the new building is going to look like. It increased in size to 1,000 square feet. It'll be fire hardened, steel reinforced concrete building, so it'll have a metal roof and concrete masonry unit walls. It's sized to meet modern National Electric Code safety standards with the 8-foot offset, which is the main reason why it grew in size. That and the VFD drives are actually physically larger than the traditional direct across the line starters. So this 8 feet right here really drove the width of the building. The length of the building's going to remain the same, but the building is going to get a little bit wider, so that way we could have the required safety offsets. And this will house all the new electrical switchgear. So you have your new PG&E meter, the main breaker, and all the breakers for the pumps. And within that, you'll get the VFD motor starters, and they're kind of laid throughout the perimeter of the building. And then you'll have our controls box. We're also including a generator hookup on the outside. So if there needs to be, if the substation for some, let's say PG&E wanted to redo their substation and take away power from that pump station, we'd have the ability to rent a medium voltage generator and run it off a diesel in that type of scenario.
Pretty big generator.
It would be a big it's similar to the ones we used at San Geronimo during PSPS.
Locomotive engines.
Correct. Probably in the scale of 1 to 2 megawatts. Again, VFDs were specified for this project because it increases the system efficiency and operational flexibility, and we can now regulate flow at San Geronimo Treatment Plant to any flow rate between 6 million gallons per day and 20 million gallons per day. And the way that's going to work is the operator at the treatment plant will type in essentially their desired flow rate. So if they wanted 16.5 million gallons per day, a computer program is going to tell the pumps to turn on, and they'll actually find their optimal efficiency points. And so they'll actually go to full speed, but then they'll lower it down to maybe 70% of their normal speed, and maybe another pump kicks on, but it's actually more efficient to run the pumps at a slower speed rather than full speed. And it'll figure that all out in the background. And while the operator, all they have to do is worry about treating the water at the treatment plant and not trying to control flow out at Tokoloma.
Yeah, it's another one of those critical points of failure.
Correct. Okay, now we'll go through the construction timeline. Staff is looking to advertise this project next month. We got our 100% plans, specs, and cost estimate this week. And then we're looking to get under contract in spring of 2026. After that, we'll start with the critical path. So starting in summer of this year, the procurement of built-to-order electrical equipment will begin. So the contractor will put in the order for the VFDs and the switchgear, the pumps and the motors. And these aren't just sitting on a shelf anywhere. So they're built to order. And we've been told it takes roughly 12 months to get some of these equipment. So during the 12 months from this summer to next summer, there's really going to be no construction happening. We're going to be running Tokoloma just as we are today. It's at that point, summer of 2027, when staff will get together and confirm that we have adequate water storage in both Nicasio, but mostly at Kent Reservoir, and we'll discuss this with the board of directors. Assuming there's adequate water storage at Kent, we will begin the next phase of the critical path, which is actually demolishing the electrical building. And that's a 12-month period that we've written explicitly within the contract. And during that time, the pump station will be non-operational, and San Geronimo Treatment Plant will solely get water from Kent Reservoir, which is the largest of our reservoirs. And after that 12-month time frame, the pump station is expected to be started back up and project completed in fall of 2028.
And what if we're in drought?
Yeah, so if we're in a drought come summer of next year, it's at that point that we would have to delay the project. We wouldn't demo the building knowing that we're in a drought, and we will have indicators leading up to that. I don't think it'll come as a surprise, like, all of a sudden July we think we're in a drought, right? We'll be monitoring.
Are you envisioning a volume set for Kent to say if it's below X?
Yeah, so that'll be something that we have not come up with one, but we're going to work with Water Resources and say, yeah, that'll be a cutoff.
And I imagine for sure this will be a discussion with the board.
Of course.
We're taking out a significant piece of, our assets for an extended period. We'd review with the board, come up with contingency plans as needed, and really be thoughtful about moving this forward. Also, this is uniquely a project that has a payback. I don't know if you mentioned what the estimate is, but it feels like 3 to 5 years, maybe 4 to 5 year payback based on the energy savings you noted.
I've not calculated, but
yeah. What's the estimate?
It's $12.8 million.
Yeah, so
That's about 4 to 5 years.
yeah, 4-year payback. Very attractive. That's huge. Operational savings.
And it's forever.
And I know. This is such an attractive project for so many.
And it immediately reduces our energy footprint. So
Immediately.
beyond the financial payback, that's
Exactly.
an important consideration.
Immediately.
Does it make sense to have a spare? Or are you envisioning a spare?
Yeah, we have a spare.
Okay.
It's built in.
Okay. Because it's with 12 months lead time, that could be kind of tricky.
And then a contingency plan. If we're in the middle of construction and it is absolutely necessary to switch back to Nicasio, we've looked into portable pumps that we could rent. They go up to 6 million gallons per day, and they have enough head to push the water all the way to San Jeronimo treatment plant. So you could actually set these up in a row, create a manifold, and then maybe get anywhere from 12 to 18 MGD, depending on how many you rent, if that were to be the case. And again, that would
Electric?
They would be diesel as well.
Gas driven, yeah.
Gas driven. And we would utilize the contractor because theoretically they'd be on site. They'd be working on the pump station. We would utilize the contractor, write a change order and say, hey, we need to pivot right now. They would go rent it and install it. So it'd be fairly seamless and wouldn't tax our operational staff. So in summary, Tokoloma Pump Station project focuses on restoring critical water supply pump facility to modern operational safety and seismic standards. The engineer's estimate for construction is $12,800,000. There's sufficient fund balance available in the FY 25 through 27 budget to cover the contractor's procurement of equipment, and staff will reprioritize and identify remaining project funds in the upcoming capital budgets. Staff recommends the planning committee review and comment on the project.
Good.
Yeah, I think the first thing that I did officially on this board was join Alex and go visit Tokoloma Pump Station and check out the San Jeronimo treatment plant risks. It's eye-opening to see that it takes 3 years to move along with things like that in this public atmosphere. But I am super proud of the strategic plan that we put forward, the capital budget that we have approved, the funding for these absolutely critical efforts that has not been available for years, and that you're moving forward in an extremely thoughtful way. That Tokoloma pump station, it looks like it's straight out of Dr. Zhivago. It's so old. The parts, you have to go on eBay to find the replacements. I mean, they don't exist anymore. So this is long overdue. I'm really happy that we're moving forward with it for a number of reasons, as well as the immense risk with earthquake and other vulnerabilities at San Jeronimo. So thank you for the presentation and continue to move.
Really just very happy with the project, and it's great. I would like to I'd like to see us doing more of this, more things that save energy and reduce our footprint, and all good. Thank you.
This is the reason why we increase rates, to be able to do stuff like this and fix it. So I appreciate the effort to make this move forward.
Yeah, very similar. I think this is probably one of the early priorities that we were alerted to back in 22 when I joined the board, and it's really good to see it moving forward. Thanks a lot.
The only caution I have is, if you look at Castagna Pump Station, which is a bit engineering style architecture block, it looks a lot better than this. Are you sure you want to spend $12.8 million without changing the building? That Quonset hut thing is kind of dated.
The pump building itself, it was in good condition. It actually functions very well.
I understand.
Architecturally, it's an acquired taste.
Yes. Maybe a paint job would help it. To make it fade back.
Larry has a lot of thoughts on paint selection. So when we get to that stage, you should
paint it a
please
different
do
color.
consult.
Well, it's funny. I complimented Sonoma on the changes in the Castagna tank painting. And they apparently had quite a debate about that. Chevron was the first one I saw do it at Richmond Refinery. They painted the tanks to blend in as opposed to stand out. And it improved the appearance of their tank farm in Chevron substantially. Then the same thing happened with Castagna. I mean, it was god awful. That tan color they had with the rust on the sides. Now it's a forest green, and it just disappears into the top of the hill. And a lot can be done to reduce that impact. Maybe even screening on the fence would help.
Certainly.
It's fenced, and
Yeah.
you could do something there aesthetically, for a few $100,000 that would make it look better. Even maybe trees or firs, or cypresses, or something like that. That could help. It's a physical
It's at
appearance.
the end of a dead end road, right?
Yeah, it is.
Not a lot of traffic out there.
No,
Yeah.
No, I believe only if you take that road you can see it. I do not believe you can see it from Platform Bridge Road. There's too much trees.
A lot of vegetation in the creek that screens it from the main road too. So there's only just a resident that lives out there. But we could look into it.
yeah, it can't hurt.
Yeah.
I'm pleased with your concerns about the board's input. I'm not as optimistic as you are that our input will be useful, but of course we'll listen. This is a pretty high tech situation, and obviously in terms of funding, there are many ways to fund these things. Bonds are obviously one way to do it. Rates are another. So I think we need to be very careful in how monies are, where they're chosen to take from, because, a project like this has a long-term return. And logically, to me, this is the kind of thing that bond would be a good choice for, because it has a long-term benefit. So with that, public comment?
Yes, Mr. Groves, please.
Sorry, Groves. I just have two questions about clarification. One is, are these motors likely to get affected by the rare earth availability? I don't know whether they have heavy duty permanent magnets in them or whether they're all electrical. So that was one question. Second question is, I appreciated that there's a potential risk associated with drought and the destruction of the electrical building as a first step. Is the footprint of that area big enough you could just put the electrical building somewhere else? And then you can do things in parallel. I don't really see why you have to take that risk unless it's absolutely necessary.
Thank you. There are no further speakers.
Any thoughts on that, Zach?
Not turning on.
That one's dead, looked like.
We are limited in our footprint there. The pump station itself is maximizing the limits within our property boundaries, and we're surrounded by National Park Service owned land. It's not a private owner, it's the federal government, so it could be a long time if we wanted to increase our property size.
It's an interesting comment, though.
It is.
It's really putting all your eggs in one basket.
In terms of risk of
What
moving
we're
forward
doing,
with
yeah,
the project,
proposing to do.
yes, but with the understanding of the contingency plan that Zach noted, right? We could and will plan for that in the event of an emergency of bringing in the backup diesel run pump. So with that, you're, I think, largely mitigating, assuming you don't move forward, of course, in a drought or near drought condition. And that's what I was talking about, having that discussion with the board.
I see.
Yeah, for rough numbers, Kent Reservoir is about 34,000 acre feet. Sandrone Treatment Plant annually uses 12,000 acre feet of raw water, so about a third of Kent Reservoir's capacity. So, if Kent is in really good condition or is high during that summer, there should be ample storage within Kent Reservoir to supply Sandrone Treatment Plant.
Okay. Thank you all. Our next meeting. There's a closed session after this?
Yes.
Okay. Is February 10th, and then we have a closed session coming after this meeting.
We'll reconvene.
Yeah,
There's no public comment on the closed session.
okay. The closed session adjourned at 10:40 with no reportable action.
Thank you. And meetings adjourned. Meetings adjourned.
Meeting's adjourned.
Thank you.